do you really hate, Josh? Darth Vader, George Costanza, Plankton, or people who say, flow makes it go?
Well, if we're talking about hydraulics, I have to say electrics.
Seems like they've been battling each other forever.
True, but today I'd like to talk about what is not different.
Okay.
To be honest, more is familiar with the two forms of energy than is different, especially from a physical perspective. If you're an expert in either industry, you already know more about the other topic than you realize. Both hydraulics and electrics involve quantities of energy being transmitted to achieve work.
Sure.
The hydraulic method of achieving work is to apply force to an actuator, which in turn moves a load. The electric method of achieving work is to apply force to an actuator, which in turn moves a load. I use the word actuator to describe any device which can convert one form of energy into mechanical energy. In the case of hydraulics, these actuators are hydraulic cylinders and hydraulic motors. In the case of electrics, these actuators are linear motors and electric motors. The electric linear motor uses electromagnets to glide a load to and fro, but I see no reason that an electric cylinder can't be manufactured with a neodymium piston and a wire coil barrel. If this hasn't already been invented yet, please send me an email with instructions on where to send my royalty checks when you steal my idea.
So what about physics, force, pressure, and all that?
What allows any physical object to move is force. Force must be applied to create motion, and I can think of no exception to this rule. Force in hydraulics is created by pressure, and force in electrics is created by voltage. The application of hydraulic force, i.e. pressure, and electric force, voltage, doesn't matter, because they're essentially the same thing. Pressure is the intensity or magnitude of hydraulic energy. The higher that intensity, the more potential there is to do work. Electrical engineers will notice I use the word potential, as it is used in the electrical kingdom. Voltage is also the measure of electrical intensity or magnitude, and it represents the potential to do work.
Well, why is the word potential so important here?
The word potential is used because it doesn't matter how high the magnitude. If the opposing force has the same magnitude, no work can be achieved. What really matters is the difference between the force going into the equation and the resistance to that force. For example, if you're putting 5,000 psi into a hydraulic motor creating 100 foot-pounds of torque, but your load is resisting with 10,000 foot-pounds of torque, raising the pressure to 10,000 psi does nothing but give you a paltry 200 foot-pounds. However, if your load were just 25 foot-pounds, our potential is more than enough to create work. The same principle applies to voltage. The higher the voltage, the harder the electrons are trying to push. At the lower the downstream voltage, the higher the potential.
Okay.
I hope it's clear that voltage and pressure are similar principles, and they can even be controlled in similar fashions with voltage and pressure regulators. But their similarities do not stop there. The other component of power is the factor of time. When converting energy, it's just as useful to push twice as fast as it is to push twice as hard. For hydraulics, the time component of power is flow, i.e. gallons per minute. And with electrics, the time component of power is amperes, which is coulombs per second. Essentially, flow in amps are the rate in which you're creating force through pressure and voltage. Flow is the volume of fluid molecules moving past a single point, and amperage is the number of charge-carrying electrons moving past a single point, in both cases over a specified period of time. Power in either example is the combined factors of either pressure and flow, or voltage and amperage. Both even use the same equation. For example, horsepower equals pressure or voltage times flow or amperage divided by a constant.
Great. Thanks, Josh. Check out all of our fluid power videos online at www.fluidpowerworld.com. Thanks for watching.